So let me talk a little bit about kind of the background of synthetic division. Synthetic division. Again, this is an alternate method to long division. Okay. So um, if we had, say, x cubed divided by x, right? The answer would be this, if we were to break this down, would be x times x times x divided by x. And then the x's will cancel, one of the x's will cancel, right? One pair of them. And you'll have x times x, which is equal to x squared. So when you divide by x, it reduces that whole, technically this is a polynomial, right? By one, right? So it is the same with, we're dealing with dividing polynomials. So, um, so if we had x cubed plus x squared minus 7x plus 2, okay, if the if one of the numbers that we pick, okay, is a factor of this, then your result will be like one binomial and the other one will be a trinomial. So it'll be like x, you know, plus minus some number a, and then x squared plus or minus a plus or minus b, right? Ax plus b. It'll be in this format because when you multiply x times x squared plus or minus ax plus or minus b, okay, then you will get equals to x cubed, right? You get back to what you have originally when you multiply this out, right? So that's what I mean by when you, anyway, dot, 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 this goes on. This is what I mean by it reduces by a power of x because of this, okay? This part here that I'm discussing. But when you multiply back out, you get that long polynomial again. Okay? So anyway, so that's basically the background. That's what's happening here. All right. So again, you can do long division. Okay. Oh shoot. This is divided by x minus 2. Okay. So you can do long divisions where we have x minus 2 and then x cubed plus x squared minus 7x plus 1. Of course, there's more to this than this, but um, it's beyond what we're trying to learn right now. Okay? So you can do long division, divide this um, rational function. Rational just means you can write it in a fraction form. You can write it this way and do it this way, or you can do synthetic division. Again, synthetic division means you will take the coefficients of the what your um, the numerator, okay? You put the coefficients or you list them in this format where you have x cubed, the coefficient of that is 1. Let me use a different color here. So 1, 1, minus 7, and plus 1, right? Those are their coefficients. So I list them here. 1, 1, minus 7, and 1. Okay? So right? So what you want to do now is you want to find um, basically they're called roots, okay, that will divide into um, this polynomial, okay? Um, I should say factors, all right? So we have one here that's given to us, which is the x minus 2. Okay. So to find out what number we put in here, okay, it's going to derive from this, what we have here, the x minus 2. So again, it's beyond what we're learning in regards to the deeper side of this. So I'm just telling you that the next step is after we list our coefficients, we need to take this x minus 2, set it equal to 0, and solve. So that gives us 2. Okay. So then that's the number we place here on the left side of this diagram. Okay. So this will be 2. All right. So anyway, so this is our setup for synthetic division. We list our coefficients and then we put the possible root, okay, that goes in here. Okay. Root just basically means that when you plug in the value, the result is equal to 0, meaning it's an intercept for that polynomial. Okay. If you don't get a result of 0, that means it's not a root. And that's okay. It can be still part of that factor. Okay. Or in this case, you'll have a remainder. All right. So here we have we're using 2, so what we need to do is we need to bring this 1 down, okay, and then we multiply. 2 times 1, we bring that over, gives us 2, and then we add. 1 plus 2 gives us 3, and then we multiply again. 2 times 3, well, that's going to give us 6. Then we add. -6 plus 6 is -1, and then we multiply again. 2 times -1 is -2, and then we add. Okay, oh shoot. Okay, I'm going to change this for a second. I miswrote something here. So this is actually supposed to be 2, not a 1. So this is a 2. Everything else is right, except that last number there. So this number is 2. I just miswrote it. Okay. All right, so then when we add this, we're going to get 0, okay? And again, if the result here is 0, that means 2 is the root of that. Again, what that means is you have a polynomial. Maybe the polynomial, looks something like this. I don't, actually, yeah. All right, maybe the polynomial looks something like that. I know that it's going to cross the x-axis 3 times because we have a power of 3 that tells us that we should have 3 possible solutions. So it's saying that one of these here, that's what we're looking for. That's what I mean by a root. Okay? Or sometimes they call them zeros. All right? So if you get a 0 here at the end, then it tells you that this is a root. Okay? That it crosses the x-axis. That's all that's saying. Okay? But if this number is not 0, that means it's not a root. Okay? It's not a root. And you'll have a remainder. Right? Okay, so then after we do this, then we set this up in factored form. So we had original of this till whatever we had here, but this was positive 2. In factored form, to be a -2 because that's what we had originally. Okay, so that will be x minus 2. And as I mentioned here, that once you reduce by x, that power also reduces by 1. So we had x cubed. So now these are going to be the coefficients of our new trinomial or polynomial. So this would be x, it would be 1x squared plus 3x minus 1. Okay? Anyway, so this would be, then I will continue to factor this. All right. To find out what the other roots are. I already know one of them. That was, say, 2. Okay. Then I would use maybe quadratic formula or something like that to find the other roots. Or if I can just factor it evenly. But anyway, that's if we're looking for the roots. But in this case, all they want us to do is when we divide this, you know, what's going to be our final result. Okay. So in this case, we would have x squared plus 3x minus 1. We have a remainder of 0. So actually, this would be our answer here. Oops. All right, that would be answer there. If we had a remainder, say the remainder was, say, 5, then we would say 5 plus 5 over x minus 2. If we had a remainder. If we had a remainder. Okay, all right. But again, we don't have it, so our answer is just x squared plus 3x minus 1. Okay. Let me do another one here, just again, just to make sure we understand this. So again, the next problem I want to do is synthetic division. I've given you a little bit of the background, what's happening here. So then we'll just go straight to it. So again, synthetic division. So let's say that we want to, you know, divide these. So you have x cubed plus x squared minus 2x plus 12 divided by x plus 3. Okay, so again, for synthetic division, I just list my coefficients here. So that would be 1, 1, minus 2, and 12. Okay, so those are the coefficients of my polynomial in the numerator. And then whatever this is a plus 3. So what I write down here is going to be the opposite. Okay, so it'll be a minus 3. Okay, and then I go through the process. So I bring down the 1, then I multiply. Negative 3 times 1 is negative 3. Add them gives me negative 2. Same thing, negative 3 times negative 2 is a positive 6. Add them will give me a positive 4. Negative 3 times 4 is 12. Okay. Negative 12. So I add them. That gives us a remainder of 0. So then this here, I rewrite this as x squared minus 2x plus 4. And then that will be our final answer there. And also I want to mention the most important part about synthetic division is that what you're dividing by, okay? This part here. As I mentioned before, you can only do this when you have a factor like x plus 3. So x minus 2, x plus 5, x plus minus whatever number you want, it will work. However, okay, it will not work where like say x squared or x squared minus 4 or an x squared plus x plus 3 or x cubed minus 2x plus 5. Okay, so if the power here is bigger than 1, you cannot use synthetic division. It only works when the power is 1. Okay, remember that. All right, so we have this problem here. So we want to do is we have the given to us, we have the slope of 4/5 and it passes through the point 1, 4. I'm going to show you two ways how to do this. One, probably the easiest way is the point slope form. Okay, so in the point slope form, we have y minus y1 is equal to m times x minus x1. Okay, so I just plug in the values that they give me. All right, so this is our x1, y1, and this is our slope, 4/5. So we have 4/5 times that by x minus x1, which is 1, and then we have y minus y1, which is 4. Okay, so if they wanted the answer in point slope form, we're done. This is it. That's our answer in point slope form. Now, if we want to transfer it to a slope intercept form, well, we can easily do that. We can just multiply the 4/5 here to each term and then bring over the minus 4. So in this case, we'll have y minus 4 equals 4/5 x minus 4/5, okay? Then I'm going to add 4 on both sides. So we get y is equal to 4/5 x, and then negative 4/5 plus 4. Well, I need to multiply this by 5/5, right? Because in order for us to add or subtract fractions, we need the same common denominator. So this becomes negative 4/5 plus 20/5. And then we have negative 4 plus 20/5, which gives us 16/5. So this is going to be plus 16/5. And that will be our final answer there. Now, if you want to use if you want to use a slope-intercept form straight off the bat, you can do that as well. So if I wanted to use slope-intercept form, it would be y is equal to mx plus b. Okay, and in this case, I would have to solve for b. Okay, so again, this would be my x and my y, and then this is my m is the 4/5. So this would be 4 equals 4/5. X is 1 plus b. All right, so then I do the same thing. I need to solve for b, so I subtract 4/5 on both sides because 4/5 times 1 is 4/5. So this would be 4 minus 1 second here. 4/5. Okay. So like we did over here, this will just be the same, right? Because this is what this is. So this here would be, I multiply this by 5/5, which is 20/5 minus 4/5, which gives us 16/5. So in this case, then we would have y is equal to 4/5 x plus 16/5. Okay, because what we saw here, this was the b, and that's what we're looking for. Anyway, so you can either, I prefer writing it in Poisson form and then just um, doing the derivative property, or if you want to go straight off the bat using the slope intercept form, you can do that too. So, but make sure you know how to do both ways. All right, so we want to divide these two. We have x cubed minus 3x squared plus 2, oops, plus x, 3x plus 2 divided by x squared plus 1. Okay, so in this case, can I use synthetic division? Yes or no? No, right? I can't use it because we have a power of 2. So we cannot use synthetic division. So that means we have to do long division. All right. So we have x squared plus 1. And then we have x cubed minus 3x squared plus 3x plus 2. All right. So what we want to do is we want to match those first terms. Okay. So I want to match this term with this term. So I need to figure out, okay, what can I multiply x squared plus 1 to give me x cubed, right? So x squared plus 1. So what would that be? Would I multiply the x squared to give me x cubed? Anyone? Again, what can I multiply to x square to give me x cubed? Yeah, x, right? X times x squared is x cubed because x1 plus 2 will give me x cubed, right? When you multiply polynomials, you add the powers, okay? So that's what we want. All right, so I'm going to multiply this by x, okay? And then I'll put my x here, and then I just distribute. So that gives me x cubed plus x, okay? So x cubed plus x. And then I subtract. I subtract the whole thing. So x cubed minus x cubed is 0. Minus 3x squared, well, there's nothing here, so that's just going to give me still the same. Minus 3x squared. And then I got 3x minus x is a positive 2x. And then I bring down the 2. So that will be a plus 2. All right. Then I go through the same process again. And what can I multiply? X squared plus 1. Okay. To give me, in this case, a negative 3x squared. So what can I multiply to x squared to give me a negative 3x squared? Yep, exactly, right? Negative 3 times x squared is negative 3x squared. Okay, so that's what I need to multiply by. So negative 3, multiply that. That's going to give me a negative 3x squared plus 3. Sorry, minus 3, right? Because I'm negative 3x squared, negative 3 times 1 is a negative 3. Then we subtract. So negative 3x squared, a minus minus is a positive, so that gives me a 0. Then I bring down the 2x, and then 2 minus minus 3, that's a positive 3, right? 2 minus minus 3, that's 2 plus 3, which gives us a positive 5. Okay, so I have my minus 3 there. Okay. So, all right, so again, my final answer is going to be x minus 3, and then we have, this is our remainder, right? That's our remainder. So that's going to be 2x plus 5 divided by x squared plus 1. And then that will be our final answer. All right, so let's say we have, I'm just making this up. So let's say we have y is equal to 3x minus 1. And we want it to go through the point, say, 2, 3. Okay. So it goes through this point. So we want to find one that's parallel, right? One equation that's parallel, and the other one we want to find one that's perpendicular. All right. So parallel, that means what? The slopes are the same. Slopes are the same. So if we have y equals to x minus 1, I need to pull that slope. M is 3, because that is what means to be parallel. But in perpendicular, it would means they are they form a 90-degree angle, right? 90-degree angle. So that means that the product of those two has to equal -1. So if one was 3, then the negative reciprocal will be -1/3. Okay, which gives us the -1 when we multiply that. Okay, so so in this case, if I were to find the perpendicular slope, that would be, remember, this is the symbol for perpendicular, it would be -1/3. It's the negative reciprocal of that, basically the opposite. of it. Okay. So this is parallel and then this is perpendicular. So, and then the rest is using the other information that we have. So I recommend using point slope form. Again, that's just me, that's my preference, but you can use slope intercept form if you want to. But point slope form I feel like is so much easier. So y minus y1 equals m times x minus x1. Okay? Then I just plug in my information. All right, so this is my x1, y1. Plug it in. Y minus 3. My slope is 3. X minus 2. And then I just simplify because they want this answer in slope-intercept form. Okay, if it was point slope form, we're done. We don't have to do anything. Slope-intercept form, that's y equals mx plus b. So I distribute the 3. So that gives us 3x minus 6. And then I add 3 to both sides. So that gives us 3x minus 3. So this is the equation that's parallel to 3x minus 1. All right. Now, if I were to do the other one, okay, so and perpendicular, it would be y minus y1 again, m times x minus x1. So I have y, my y1 is 3. My slope now is going to be the negative 1/3 because we're talking about perpendicular. And then we have minus 2. So then I just simplify this. So I get negative 1/3 x plus 2/3, right? And I multiply that. Then I'm going to bring that 3 over. So this would be a plus 3 here. Okay? All right? So then that cancels there, giving me 3 here. So we have 2/3 plus 3. Well, 2/3 plus 3. So I need to have the same common denominator. So that gives me 2/3 plus 9 over 3, which is 11 over 3. All right. So my final answer here is going to be y is equal to negative 1/3 x plus 11 over 3. So that would be my perpendicular line. All right, so I entered this in the graphing area calculator here. So if I have y equals 3x minus 1, it would look like that. If I wanted an equation that was parallel, we found that out. So this would be the equation that's parallel to it. Okay. And if you want something perpendicular, then this is the green line would be the perpendicular line to that. So it forms that 90-degree angle. Okay. So parallel and then perpendicular. Okay, another good problem to look at are the exponents rule. Okay. So before I remember PEMDAS, right? Please excuse my dear Aunt Sally. So we work inside the parentheses first, and then we do the exponents. So I recommend working inside the parentheses first. So in this case, right, we get what? 2/3, we can't do anything with that. That cannot be reduced any further, so we leave that alone. We have x4 over x3. Well, I can take out all the x's here, and I have one left over here. So I have x. This one here, I could bring it to the top. So that becomes 2 plus 3, which gives us 5. So this becomes y to the 5th. Okay? And then this is being raised to the power of 2. Now I can distribute that too. So this is 2x raised to the second power, y fifth raised to the second power, and then 3 raised to the second power. So that gives us 4x squared, y to the 10th over 9. All right, so remember what we want to do is we want to work inside the parentheses first, all right? And then we can raise it to the power. So we have a to negative 5 divided by 2a. So what I can do is I can bring the a to negative 5 downstairs. So I'll have b over 2 on top still. And then I'll have 2 times a and then a to the power of 5. And then b negative 2. Now what I can do with that b negative 2 is I can bring now this to the top. So that, excuse me, that becomes b to the power of 2. Okay. So then this becomes b4 over 2a to the sixth power. Okay. All right. Then I can raise it to the power of negative 2. So then now I can just either distribute, or what I can do is that negative means I can flip inside inside that parentheses. Okay. So all right, so when I flip that, this is going to give us, so I'm just going to flip it because again, I have a negative. I can just flip this here. So 2a to the sixth divided by b to the fourth, now raised to the power of 2. Okay, all right, or you could have distributed negative 2 to each of the terms, and you can do it that way too, but this one I feel like is a lot more easier. So then now I can distribute this. So this is becomes 2 square times a6 to the power of 2 and then b4 to the power of 2. All right, so that gives us 4 times a to the 12 divided by b to the 8th. All right, so this one is another problem you can practice. We got 4m divided by 3n. Sorry, yeah, 4m divided by 3n divided by, or say 4m over 3n divided by 9m over 5. See if we can figure this one out. All right, so remember how to do this is we keep the first term, right? So that'll be 4m divided by 3n. And then we change the division to multiplication. And then we flip this. So that's 5 over 9m. Okay? And then we just multiply. So 4m times 5, that's going to give us 20m. And then 3 times 9 is going to give us 27. And so that's going to give us mn. And then we can cancel out the m's. Okay. And there's nothing else that we can do to reduce 20 over 27. So our answer is going to be 20 over 27m. Sorry, n, not m. All right, so for this one, we want to solve for x. So there's a lot of ways to do this, but probably the easiest way is we want to move the let's move the y over. Okay. So minus y, that gives us z minus y equals negative 3xy. Okay. And then again, we want to get x by itself. So then we have to divide everything by negative 3y. Okay. So then the negative 3's cancel and the y's cancel. So we have z minus y over negative 3y. Now, don't be tempted to try to cancel these guys out. That's not true. You can only do that if they both have a common factor of y. So this had to have a y as well in order to do it. So since it doesn't, so you can't do it. So you can leave your answer this way, or if you want to make it positive, or you can write it this way. Put the negative in the front. Okay, you can do that. Or you can put that negative and put it in the top and then distribute, giving you negative z plus y over 3y. A lot of times the lab likes doing it this way, okay, because I don't like the negative there. But anyway, any of these will work. So all of this here are all equal to each other. Okay, so what's going to be our LCD here? What's our LCD? What's our LCD? Yep, 20, right? 20 is our LCD. Because we have a rational equation, that means we want to get rid of the denominator. So we multiply everything by 20. Okay? So that gives us 20R is equal to 20 divided by 4 is 5, right? So we'll have 5 here. So we have 5x, and then 20 divided by 5 is 4. Okay? So we have plus 4y. All right? And then our goal was to solve for x, so we're going to subtract 4y on both sides. Okay, so we have 20r minus 4y is equal to 5x, and divide everything by 5. Okay, so we have 20r minus 4y over 5. Again, don't be tempted to say, oh, this will go to in 4 times, that's 0, or 1 time. Don't do that. That is not correct. You can only cancel things out if they have a common factor. So if this was like a 5 here, then you can cancel them out. Okay? I see that a lot. Anyway, so that would be our final answer there.